Hi, my name is Adam Dzyzanowski. I'm an embedded software engineer, and I want to talk about a project I worked on recently. I haven't had much professional experience working with real-time operating systems, so I figured the best way to fix that would be to write my own. So I ended up with the appropriately titled HobbyOS, which includes, of course, preemptive scheduling, as well as software timers, queues, and the like. And once I had done that, of course, I needed a robot to actually test it out and show that it worked. So I ended up using Parallax's Board of Education shield as the base of the robot, so this includes the frame, the motors, the encoders, that sort of thing. For the brains, I laid out my own PCB. This includes a PIC32 chip, and so this interfaces with the Board of Education shield, as well as the other components on this robot. So the actual function is fairly straightforward. I use this Wiimote to drive the robot around, and as it's driving, the encoders on each wheel record the spokes turning in front of their sensors, and so that gives us an idea of how far each wheel has moved for a certain block of time, in this case every tenth of a second. So that information also gets displayed on a little LCD on the top of the robot, as well as being recorded to an SD card. Doing so allows us to then later, with a Python script I wrote, recreate the path of the robot using a technique called dead reckoning.
So let's try it out. This is a recording of me driving the robot around, and on the bottom right is the Python script actually replaying the data from this run. Now, one issue with dead reckoning is that errors build up over time, and you'll see the positions start to diverge between the two. There's a couple reasons for this. The wheels could be slipping, which won't be recorded accurately. Our encoders aren't particularly accurate in the first place. There's only 32 spokes per wheel. But there's a couple ways we could help fix this. Adding an accelerometer would give us additional movement information, or having some way to look at our surroundings and reorient our position would prevent those errors from just building up. Because you can see at this point, our positions have diverged fairly heavily between the two. But despite that, the actual movement, the sort of local movement you can see, is being recorded fairly accurately. It's just our position is so far off. This was a really fun project for me, and I think I succeeded in learning more about real-time operating systems, as well as stretching my legs on prototyping, PCB layout, and all the other fun embedded system stuff.
The code is all open source, so you can go take a look at it on GitHub. The links are below, and thank you for watching.